Okay, so this week we're going to be talking about two concepts. So point in a plane and reference angles. And then you'll see kind of how all of this connects when we talk about the unit circle next week. So point in a plane is going to actually be going back using our trig functions that we talked about a few weeks ago. So we're going to start by reviewing those, and then we're also going to add on the inverse trig functions. So remember sine of theta, so theta is just our angle symbol, was opposite over hypotenuse. Cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. Now, the inverse functions are just that, inverses. So cosecant has to deal with sine. It's the inverse of sine. So instead of opposite over hypotenuse, I would take the hypotenuse over the opposite. Secant then goes along with cosine and is the hypotenuse over the adjacent side. And cotangent is the inverse of tangent. So the adjacent over the opposite. So point in a plane typically gives you either a point on a coordinate plane drawn in a graph or just the point. So we're going to do a few examples where I'll give you the point, we're going to draw the graph, and then come up with the sine, cosine, tangent, and then cosecant, secant, and cotangent. So it says use the given point on the terminal side of the angle theta to find the value of the trigonometric function indicated. So the first one we're going to start by doing is we're going to do 5, negative 12. So I want to start off by graphing this like I would any other coordinate point. So I'm going to go right 5 and down 12. And they tell me that this is on the terminal side of our angle. So here's my ray for the terminal side. So what I want to start by doing is creating a triangle with that terminal side and the x-axis. So I'm just going to draw a vertical line there. Now, if this point is 5, negative 12, I know that I went right 5 units and down 12 units. So this is positive 5, this is negative 12. Before I can actually lay out my trig functions, I need to come up with a hypotenuse. So we're going to use Pythagorean theorem to do that. So remember, Pythagorean theorem is just a squared plus b squared plus equals c squared. So I have 5 squared plus negative 12 squared equals c squared. So 25 plus 144 or 169 equals c squared. Take the square root of both sides and I get 13 is my hypotenuse or side C. So now lastly, before I come up with my trig functions, I want to label my sides. Well, the first thing we need to figure out is where is that angle? So the angle always goes right next to the origin, okay? You have 3 options. It always goes directly next to the origin. So that means across from that, negative 12 is my opposite side. The hypotenuse is always across from the right angle. And then that leaves me with the adjacent side up here. Okay, so we should have everything that we need to come up with sine, cosine, tangent, and then our reciprocal functions, cosecant, secant, and cotangent. So sine we know is opposite over hypotenuse, so negative 12 over 13. And then cosecant is just the reciprocal of that, so 13 over negative 12. Cosine, adjacent over hypotenuse, so 5 over 13. And then secant is the reciprocal, 13 over 5. And then finally tangent is opposite over adjacent. And then cotangent would be 5 divided by negative 12. Okay, so we're going to do 2 more examples. The second example is negative square root of 19, comma 9. So again, I'm going to start by drawing a picture to go along with this. So I set up my coordinate plane. I need to figure out which quadrant this coordinate point is going to be in. So if I'm going left, negative square root of 19, and then up 9, that means it's in quadrant 2. And then remember the terminal side of my angle goes through that point. So I'm going to set up a triangle with the x-axis. So this time I'm just going to draw a vertical line down to that x-axis. And I need to label this. So I went left, negative square root of 19, and then I went up 9. And remember, your angle always goes right next to the origin. So I have my triangle. Now I need to figure out that hypotenuse. So again, I'm just going to use Pythagorean theorem. So I have negative square root of 19 squared plus 9 squared equals c squared. So when I square negative square root of 19, keep in mind a negative times a negative is a positive, and the opposite of square rooting something is to square it. So this actually becomes 19 plus 81 equals c squared. So 19 plus 81 is 100. I take the square root of both sides and I get c equals 10. So that's my hypotenuse. So again, it's always helpful to label. And then this time I might actually grab another color here. So across from my angle is the opposite side. My hypotenuse is always across from that right angle or the longest side, and then I'm left with my adjacent side. So again, we want to come up with sine, cosine, tangent, and then all of our reciprocal functions. So we have cosecant, secant, and cotangent. So sine of theta opposite over hypotenuse is just 9 over 10. And that means cosecant is 10 over 9. Cosine adjacent over hypotenuse is negative square root of 19 over 10. And then secant is 10 divided by negative square root of 19. Now, we run into a little bit of an issue here. So in math, we're kind of taught that you should never have a square root in the denominator. So what we end up doing is called rationalizing the denominator. I want to get rid of that square root in the denominator. So in order to do so, I'm going to multiply both numerator and denominator by the square root of 19. The reason is, on the numerator, I'm left with just 10 square root 19, because we just multiply across. In the denominator, keep in mind, if I'm doing square root of 19 times square root of 19, I'm essentially squaring it. So the square and the square root cancel each other out. So I'm just left with negative 19 because the sign does not change. We're going to do a few more examples like that. So lastly, tangent, opposite over adjacent. So 9 divided by negative root 19. So again, in this case, I need to rationalize. So I multiply numerator and denominator by square root of 19. So in the numerator, I get 9 square root 19. In denominator, those square roots cancel out, so it's just negative 19. And then lastly, cotangent is negative square root of 19 divided by 9. Okay, I'm going to pause for just a moment, and then we're going to do one last example. Okay, time for our last example. So our last one is 2, 5. So again, I'm going to draw my graph. So I go right 2, up 5. So that's the terminal side of my angle passes through that point. So imagine it'd be right about here. Again, I want to create a triangle with the x-axis. So I'm going to draw a vertical line straight down. So I went right 2, up 5. My angle goes right here. I need to figure out the hypotenuse. So I use Pythagorean's theorem, 2 squared plus 5 squared equals c squared. So I end up with 4 plus 25 equals c squared. So 29. So I go to take the square root of both sides. But 29 is not a perfect square, and you also cannot simplify this. So I would actually just write this as C equals the square root of 29. And I'm going to put that in my hypotenuse. It might help to make your pictures a little bigger than mine. And then finally, I'm going to label this before I get started. So across from my angle is the opposite. Here's my hypotenuse, and then I have my adjacent. Okay, so first we want to come up with sine of theta. So remember, sine is opposite over hypotenuse. So 5 divided by the square root of 29. Here's another example where we need to rationalize that denominator. So I'm going to multiply both numerator and denominator by square root of 29. So in the numerator, I end up with 5 root 29. And the denominator, root 29 times root 29 is just 29. And then I'm going to do cosecant next. So the reciprocal, instead of 5 divided by square root of 29, it's just square root of 29 over 5. Next up is cosine of theta. So adjacent over hypotenuse, 2 divided by the square root of 29. Again, I need to rationalize. You might already kind of expect at this point, okay, well, if I multiply square root of 29 over square root of 29, I know that I'm going to get 2 root 29 over 29. And then for secant of theta, it's just the square root of 29 divided by 2. And finally, tangent of theta. So opposite over adjacent is 5 divided by 2. And then cotangent of theta equals 2 divided by 5. Okay, so I'm going to stop the video here. I have a few practice examples for you to do today, and then tomorrow you'll have a Canvas quiz on the same material. Feel free to rewind, pause, rewatch as many times as you need to. Have a good day.